So we'll come back here now to the flows. We have withdraw and deposit flow. Yeah, so we can. So out. Let's see. Let's leave out this flow. Let's come here. Let's write a withdraw flow before a deposit flow, and let's see what happens. Let's see how it works. We can do it here still. It's for withdrawing. This is getting pretty long. Yeah, I cut it into two. Withdraw from vault. We have construct. Now, the simple way, like I said, still the same thing. Construct instruction data. We are mirroring this. I'm mirroring this withdraw here. So we have user account, owner, and vault. 4 accounts to be passed in. So come here. Construct instruction data. Yeah, so we have so first things, not construction data rather. Now here we have get slash init accounts. So these accounts that have been initialized in the first part, we use them here. So the first point is to get accounts. Let me show you what I mean. Everything I see, I picked most of them from here. So constructing instructions, you can see in flows, frozen flows. But you'll see that if you check it well. So once you've initialized an account here, we can get that account. That's the point of initializing. So you have, what are we using here? We're using user accounts owner and vault. So let's user equal to self dot this is how it works pretty less. So do that for user account. This will make us work faster. So the video is not too long and boring. So you have this user account vault, and then we have Chora one. Yeah, these are the 3 accounts we are using. Then construct instruction data. Yeah, we still have construct instruction. No, just the instruction data, then execute transaction, then invariant checks. So next step is to input, just say input equal to, just like to use the same self or trident. So in coming videos, we'll talk about how to force proper, because some of these inputs, you need to know how to select inputs for forcing so they match. A vault that would handle 2 billion soul and you're using maybe just 100 lamp pots, it's not give you what you want. So you need to force properly. Remember, it's guided forcing, so you have to guide it proper. Know the rules behind forcing and use them proper. Construct instruction, same way. Withdraw instruction data, withdraw instruction data. We have inputs, and we have the accounts. We have this here. This is the same thing, the instruction. This is not imported. Here, then we convert this. Takes in 4 arguments. User account, owner. Okay, so just passing in user account twice. Just passing user twice. Yo. So we have this. Does this work now? Yeah, this works. Then execute instruction. We have this. Let's test it out quickly. Now, there's what we call iterations. We have them here. So this determines how many times this will run. 1000 iteration, 100 flows per core. So how many times do we have to swap per core? Then how many times do we have to run each iteration? This is what it does. First test, false. So we have it here. Now we can see all withdraw instruction field. What happened? account owned by wrong program, we are picking the wrong thing. The given account is owned by a different program than expected. What account is that? Caused by account votes. Wow. So yeah, after checking this out, I think we have issues with how I arrange them. We have user account, owner votes, and user account. So votes supposed to come last. Yeah. So order of arrangement matters as usual. I think I didn't pay attention to that initially. Yeah, you won't. So reduce number of iterations, but in so reducing number of iterations, reduce number of inputs that I have to send in. So for this one, I'll just do that. Then, but when you're testing the program that's about to go live, it's advised to run thousands, 10,000 of iterations and leave it. Probably you can leave it like hours. So you test different use cases and see. Yeah, so this is quite difficult for us to navigate. So just run the regular. I'll use 100. Yeah, so you can see our withdrawal instructions, insufficient funds for withdrawal, meaning that we've not deposited here. So everything failed. Let's run the deposit quickly. So I think it's from there we can now. So what I'm saying is this is the secure version per se here. So we can see that withdrawals don't go through if no matter the amount given. But if this was written on the vulnerable version, we'd probably have withdrawals go through. Yes. Let's see if we can quickly do that. If we do trident in its was trident in its vulnerable. Mm, it's a way to initialize a if we move to it's a way to initialize it with particular program where you have like multi-program directory. Okay, dash p. Yeah, so we have trident init dash p vulnerable. Mm. Trident for that. Sorry, Trident false dash p vulnerable. So we have that here. Let me quickly show you. So let's write these same things for these. We'll just copy and paste quickly. Copy this part, paste into the init part of this. Copy this part. Mm. Yeah, we have to initialize. We have to import all that. Let's be sure it's important from the vulnerable here. Remember, this is secure vulnerable. The secure version protects the account from protects the program from integer overflow vulnerability. Why the vulnerable version is just written normally. So let's see what happens when you try to withdraw when you've not deposited in a vulnerable program. The reason why we know this is vulnerable and secure is because I already termed it that. Imagine you are just forcing an existing, sorry, something to be vulnerable. Yeah. So I might cut this video into two. Yeah, so it's easier to watch. So we have all this. I think this is fine enough to so we come here, we see the same function, sorry, the same command, but this time let's see the name of this. This is first one. So we just run first one. Let's see what happens. Yeah, we can see some of the withdrawal instructions passing. You see what I'm saying? So this is what Fuzzing helps you do. Like you can see the attempt to subtract with overflow. The SBBF program is panicking. Yeah. Besides that, so some of the withdrawal instructions go through, which is not supposed to be for a program that hasn't collected deposits yet. We've not written deposits fuzz yet. Like there's no deposit in this fuzz yet. You can withdraw. So this is like a very big vulnerability, and this is what Fuzzing helps you catch. Yeah, I mean you could do this with unit tests, but some sophisticated programs, there are some places you won't see some of these loopholes, and with Fuzzing you can catch them. So that's pretty much it. If you add the deposit instruction now, then you can see how it plays out. But the point I was just trying to show you is that we can see withdrawal instructions going through even when there's no deposit here. So if you want to add the deposits quickly, let's do that here in the vulnerable. Let's see. So I'll just copy this, take withdrawal down. Since the flow, deposit before withdrawal, but normally even when the Trident SVM is testing, it swaps flows. So not every time withdrawal comes first. Like checking for state machine bug, so withdrawal can come before deposit. So this is just like for arrangement's sake. But when voting, when fuzzing, yeah, all these swaps. So let's check what we have here. Deposit takes in user account votes. Yeah. So yeah. So thank goodness for AI. Then state instruction data, same thing. Confirm please. Takes in an amount here, and then construct instruction. Then it's pretty smarter now. We have the key transaction. Have this. Still have to import all this. Yeah. So let's try. Let's see what happens if we run the force again. You will see some of the deposit instructions fading, some passing, and yeah. So most of the withdrawal panics because there's a wrapping sub. Yeah. But let's move this to our secure program and see how it plays out. This is just basically this video is just showing you how fuzz are written. In further videos or future videos, we'll talk about writing proper fuzz tests, like designing your model properly. Just want to show you how it works in real sense. No, we didn't switch this for 0. So we can see deposits 485, 98 successes, 387 failed. Remember, I said random inputs. Yeah. So all the initialized passed, as I said initially, create user accounts. Only 20 of the withdrawals passed and all. Yeah. So you can see we're not having panics because this one is safe. So insufficient funds for withdrawal. You can see here, see this. User deposited 801 balance and then probably trying to withdraw more than, and we get insufficient funds. So you can see it will show you what the user deposited and then trying to withdraw. Maybe the first test passed in a bigger amount than this for random sake and throws an error that sufficient funds user cannot withdraw more than has deposited. That's what first test helps you to do. So all these issues with mathematical calculations, you can test them with random inputs with first test. That's what it helps you do. So in our next video, we'll talk about invariants. I mean, invariants are used to check aftermath of a program to see if the state is how it's supposed to be. Now, this is just you passing random inputs and just observing behavior. Now, what if you want to confirm before and after scenarios, state machine bugs to see how they perform, how the system performs under random selection? Because hackers don't think the same way you think. You're thinking A, hackers are thinking B, D, C. Like, so talk about invariants, how to use invariants to actually check your program behavior and also. I'll see you in the next video. Thank you.